Yes, so thank you everyone. The next talk is by ASOS. My wife's a big fan of you, by the way. She spends far too much of her money there. And we have Duncan, Bryan, and Angelo. Duncan is a senior machine learning scientist at ASOS.com and holds a PhD from University College London. He has led various projects over his time at ASOS and is responsible for large-scale transformations in the retail operations through automated pricing and forecasting. Bryan wears two hats. He works part-time as a senior machine learning scientist, while he also working towards his PhD. He is interested in improving the controlled experiment design and causal inference methods for digital experimentation and measurement, enabling decision makers to make less biased decisions more quickly. Angelo is a senior machine learning scientist at ASOS.com and has a PhD in deep learning with a computer science background. At ASOS, Angelo leads R&D projects applying advanced machine learning methods to industry problems at scale. Round of applause for Duncan, Bryan, and Angelo, please.
Cool, thank you for that lovely introduction. I'm Duncan. I'm a senior machine learning scientist at ASOS.com. And this is our talk, modeling at a fashion company. You may have noticed I've cleverly done a wordplay on modeling there. This is going to be about modeling with data, not about modeling with clothes. So I don't know if you're disappointed by that or not. Okay, so today's talk, we're going to be doing sort of a bit of a highlights reel. I'm going to give you an introduction to the team, how the team makeup, how we work, our different roles. Bryan's then going to be telling you about some really exciting research we've been doing recently, which has been accepted for publication at NeurIPS. And then we've got Angelo at the end, and he's going to be telling you all about a project we've recently just completed, which is personalizing our search engine. Cool, so let's get into it. So who are we? So I imagine most people in the room have heard of ASOS, but for those that haven't, ASOS is a British online fashion retailer, but we're a global company and we sell clothes all over the world. Our mission is to become the world's #1 destination for fashion-loving 20-somethings, and we have 26.4 million active customers. In the last financial year, we shipped 95.2 million orders. We have around 90,000 products on our site at any one time. And last year, our group revenue was around £4 billion. So I guess the upshot of this is that we have a lot of data, and we've got a lot of data to play with. And this is where we come in. So who are we? We're the ASOS AI team. There's around 50 people in our team, but we've got a plan to grow that by about 60% over the next year. So yes, we are hiring. And we're a central team within the business, and we cover basically all the roles you need to put machine learning systems live and into production. And I'm going to give you a bit more details on exactly what they are and how that works in a few more slides. And just to give you a few more details on our team makeup. We're a diverse team. We're very proud of the fact that we have almost a gender-neutral team, so 48% of our team are female. And this is across technical and non-technical roles. There's a fairly equal split across all the different roles that we have in our team. We're also very proud of a significant representation of Black and minority ethnic colleagues, which is around 30%. And we have 16 countries and regions represented in the team as a whole, which I've put on all these flags. So you can play a sort of flag quiz game if you want. Now, what do all these wonderful people do? So this is our team makeup, and the main thing for us is that cross-functionality is key. We've been looking at different ways of organizing teams for quite a few years now, and the main thing that we know is that having a cross-functional team is super important if you want to be putting machine learning systems into production. So you'll notice that we pretty much have a one-to-one relationship between scientists and engineers, and that's not a mistake. I'll go into a bit more detail about the roles and responsibilities on the next slide. We also have product management, which is, again, hugely important. ASOS is a business that has lots of different parts to it. And we need people that are going to go into the business and understand the problems and make sure that comes back to our scientists and engineers so they can work on the correct problems and start providing value. So yeah, product management, super important. And we have our senior leadership roles that represent us at the exec level. I don't need to probably say how important that is. And finally, we have our management team, and they look after our most important asset, which are the people that we have in our team. So yeah, I just want to spend a little bit of time talking about like what different roles the scientists and engineers and product managers do in our team. So the way that we've kind of thought about it is from a machine learning lifecycle point of view. So we have this MLOps diagram. You probably hear a lot about MLOps these days. And we looked at this diagram and we thought, who needs to do these different roles and responsibilities? What part of our sort of tech stack needs to cover each part of this flow diagram? So first off, we have product management. I mean, this is a fairly straightforward one. They go to the business and they get the requirements, but business requirements and having clear business requirements is super important to any successful machine learning project. We then have data engineers. Now, data engineers, for me, it's the foundation of all machine learning projects, is to have correct and clean data. So this role is super important in terms of, it's the foundation that all of the other projects sit on, basically. We see machine learning engineers taking sole responsibility for the model kind of once it's been shipped and deployed. So this is stuff like deployment, integration with other systems, and monitoring. Scientists, it's really just, their sole responsibility is, well, I want to say the science, but it's about the training of the model, doing the research, trying out different ideas. And then finally, this section in the middle is where we try to take this sort of cross-functional approach very seriously, and it's about building feature engineering pipelines, training the models, doing offline evaluation, and then of course when it goes online, we also do online evaluation as well. And so yeah, that kind of gives you an idea of how we structure our teams. Ideally, all teams that we have will have all of these roles in them, and we generally try to keep the mix of engineer to scientist as a one-to-one relationship. So what do we actually do with those teams? What business areas do we work on? So I've got here the 3 different sort of key streams of work that we cover in our team. The first one is product discovery. If you've ever been on ASOS, you may have felt slightly overwhelmed by the amount of choice of clothing that you'll have. And so product discovery is kind of what it says on the tin. It's all about helping customers find products that they want. And this is kind of the stuff that you'd expect from an e-commerce company. So recommendations, ranking of the search results, and ranking of the category pages. And the ranking of the search results is something that Angelo is going to talk about in a lot more detail later on. As well as helping our external customers, we also help internal customers, and this is parts of the business which need some help in automating the huge operation that we have going on. And so we have a retail team which assists our commercial teams to manage their product. And this you can think of as stuff like stock forecasting, ensuring that stuff's replenished when it goes out of stock. And then secondly, yesterday was Black Friday. We discounted a huge amount of the site. In fact, all the site was discounted. Managing all those prices for an individual is pretty much impossible because we have 90,000 products. And so we have a significant effort in price optimization as well. Discounting is a huge tool for ASOS. And so basically getting the most out of changing those prices and discounting is the responsibility of this team. And finally, we're a growing business. And so we want to give our customers the best possible experience when they're with us, so they keep coming back again. And we also want to attract new customers as well. So this team focuses on things like optimizing our marketing spend, and they do things such as geo-testing. Geo-testing is a bit like an A/B test, but instead of doing a random split, you split across different geographies. And we also have a significant effort in natural language processing. All of our customer care interaction is through text, and so there's a huge scope to do natural language processing in that area and assist our customer care colleagues. Here is the tech stack slide. Everyone loves a tech stack slide. You can have 10 points if you can hit every single icon on this slide. I definitely couldn't when my engineer helped me build this. If there's any specific thing you want to talk about in this tech stack, then please come down to the booth and talk to us about it afterwards, because it would probably take me like 10 minutes to go through every single bit. We use Microsoft Azure, and we also partnership with Databricks, so you'll see quite a bit of Azure and Databricks stuff on here. I'm just going to cover the machine learning stuff because this is a machine learning talk. So we do all of our deep learning in TensorFlow and Keras. We're also massive fans of the Microsoft LightGBM library for doing boosted trees, like gradient boosted trees and that kind of thing. And because we use TensorFlow, we do a lot of our serving through TensorFlow serving, but we've also just started to do a few POCs with NVIDIA's Triton service as well. But as I said, if you want to talk about something here and there's an icon you don't recognize, then please come and talk to us afterwards. Cool. So we also partner with some of the best universities in the world. Research is really important to us, and Bryan's going to be telling you a bit more about that very shortly. So the top one is UCL's Center for Doctoral Training in Data Intensive Sciences. We sponsor students from this CDT, and they will come and do a 6-month industrial placement with us, which is really cool. And Bryan is doing a PhD with Imperial College London and the University of Oxford, part-time, and this is the EPSERC CDT in Modern Statistics, Statistical Machine Learning at Imperial and Oxford. So innovation really matters to us, and research really matters to us. We've published 15 scientific papers in the last 4 years, and I also painstakingly went around the internet and found the icon for every single conference that we published at, which was no mean feat. I've ordered them from the oldest to the most recent, and so you can see that we kind of have a fairly steady publishing rate of around 2 to 3 papers a year. And obviously the crowning glory is that we managed to publish at NeurIPS this year, which is a massive achievement. Beyond that, of course, we don't just do research, impact matters as well, so our business impact. This is just on personalization. As I said, we cover retail, more like pricing optimization, that kind of thing, and the stuff on growth as well. So this is stuff that was shared in a recent Capital Markets Day presentation, so I can share it with you now. So this is kind of an overview of the stuff we've achieved over the last 2 years. So in 2020, we released a new algorithm, which is when products first come onto the site, we don't have any customer interactions with them, so we can't use something like collaborative filtering. And so this is a purely content-based recommender that uses computer vision and NLP to make recommendations. It's very cool. In 2021, we massively increased the personalization on the website. So we had recommendations on most of our category pages, but we also rolled this out to promotion, sale, and outlet as well. And just to give you an idea of the scale that we work at in ASOS, is that we were serving around 1 billion product recommendations every single day. So it's really important that all of our services are super scalable. Angelo will touch on that later on as well. In terms of results, we see just through personalization in A/B tests, we see an increase of around 0.8 to 2.7%. This is per A/B test, not the overall. And we've also managed to increase personalization by 53% on the website in the last 2 years. And the most recent project that we've managed to roll out to 100% of app traffic is personalized search. Angelo is going to tell you a lot more about that in a second though, so I won't go into it. And yeah, that's it for me. I'd like to welcome Bryan onto the stage, who's going to be telling you about bringing stats tests and data to A/B tests.
Thank you, Duncan. Hi, everyone. Can you hear me okay? I assume so. My name's Bryan, and I'm a senior machine learning scientist here at ASOS. I work in this role part-time, and I'm also working a part-time PhD at Imperial College and Oxford, looking at how we can improve the digital experimentation and measurement capabilities. So today I'd like to share an applied research problem that I recently worked on that stems from my day-to-day job at ASOS.com, building foundational data and experimentation capabilities that helps people to measure the impact of what they're making. I know that prior to me speaking, there's already 2 talks on what an A/B test is, how can we run A/B tests, how do we build an infrastructure around it, yada, yada, yada. But just to set the scene, just to give the context, let's give a very simple A/B test example. Let's say if someone comes to you and say that, hey, do you know that if you offer free delivery to your customers are more likely to buy from your e-commerce website? You want to validate this hypothesis, and so what you do is you split randomly your incoming visitors into 2 groups, the control group and the treatment group. The control group sees the original website, and the treatment group sees a free delivery banner being featured prominently on top. Measure the activity of these 2 groups of users under some certain business metrics that you care about, and if there's a difference, you run a stats test to ascertain whether this difference is due to some random fluctuations, or if it is indicative of some causal impact of the free delivery banner. Now, as a data/machine learning scientist, there are 2 kinds of requirements I consider day in, day out in my roles. First off, there's the stats test requirements. I will be asking myself the questions. What are the assumptions that is implied by this stats test? Are the assumptions that are imposed by my business problem compatible with the set assumptions? On the other hand, there's also the data requirements. I'll be thinking, well, what is the data schema looking like? What are the columns that I need to extract the features and the variables that I need? What is the scope of each row within my data set? Does it contain a visitor activity or something more fine-grained or coarser? Now, if you look up on the internet, you'll see people talking about these 2 kinds of requirements in separate. You have a separate flowchart on what kind of stats test you should choose, and then you have a different validation process to make sure your data set is working. However, as someone working in experimentation, I argue that these 2 requirements are actually much more intricately linked. More often than I like to, actually, I'll be asking myself the questions. I need to run the stats test. How should I format my data set? How should my data set look like in order for my stats test formula to even function? On the other hand, there's another question. Let's say I have this data set, maybe collected for one purpose and being repurposed for another. What stats test can I run? Now, I'm not even getting a question of whether I should run the stats test to extract some insights. I'm just getting a question of what stats test is there? What options do I have left? Now, if I've been asking myself these 2 questions more often than I like, surely someone on the internet would have gotten annoyed enough to write a cheat sheet that maps the stats test requirements to the dataset requirements, right? Surely someone would have written a tool that says you put in a stats test and then it tells you what dataset you need to have in order to run the stats test, and vice versa. Now, unfortunately, there isn't such cheat sheet on the internet, and I just tell to myself, okay, let's be the change that I like to be, and so I have to write my own cheat sheet. So I started with the dataset side. I have to make a choice. I can either start from either, but I choose on the dataset side. I built a taxonomy so that I could categorize these datasets. Now, it's worth noting that the taxonomy does not only cover datasets that you can find for A/B tests run within ASOS, but all the A/B test datasets that you can find all around in the internet. The taxonomy considers how granular the data set is response-wise. So for example, whether each row of your data set contains a click, or maybe a user session, or maybe activity of a user, or maybe aggregated all the way up to the control and treatment group level activity. It also considers how granular it is time-wise. That is, if you have one single snapshot covering the entire experiment, or if you have multiple intermediate checkpoints that allows you to see how the activity of the users in your experiments evolve over time. It considers how many experiments are there in the dataset. So having a single experiment dataset allows you to, run the analysis to validate the hypothesis for the set experiment. But if you want to understand how your experimentation program is performing health-wise, you probably want to have multiple experiments in your dataset before you calculate some kind of metrics. And finally, the taxonomy considers whether the dataset contains real experiment data or synthetic experiment data. Now, real experiments, it's obviously good. Real experiments are obviously good if you want to understand how your real users are behaving. Sometimes, for some stats methods, it might be better to augment your real data with some synthetic data so that it runs smoother. And sometimes you want a purely synthetic data set just for educational purpose. And so having both kinds of data in your collection is a good thing. Now, having created this taxonomy, we can then able to map different statistical tests onto this taxonomy. This helps us to bridge the dataset requirements to the stats test requirements. That is, if you have the dataset, you can tell what stats test you can run, and if you have a stats test in mind, you probably know how the dataset should look like. Now we've built the taxonomy, and then we create a mapping between the datasets and the stats test. What we only need to do is to populate this taxonomy with all the datasets we can find on the internet. I was having high hopes of finding a lot of datasets that I could fill, but actually, to a bit of my shock, I can only find 13 AP test datasets being publicly available on the internet. Now, with all the organizations running all the A/B tests that people keep talking about it, you expect there are much more than 13. But no, you can only find 13, and that is bad. In particular, I was trying to run some experiments with adaptive stopping, and I can't find a single dataset that could help support the design and running of it. And you might be asking, what are experiments with adaptive stopping? Well, I'll invite you to take a step back and think about what happens with modern business practices. Regardless of which field you're in modern times, often you like to make a decision as soon as possible. You might be maybe as a product manager, maybe as a scientist, maybe as an engineer. You often get asked or asking the question, hey, that feature we're testing is looking pretty good. Can we deploy that now? Or on the other hand, you might have asking questions of, well, that feature's not looking well, it's harming our business. Can we roll that back as soon as possible? Now here, the statistically correct answer would be saying no, because it might be just some random fluctuations, and if you decide to make extra decisions before the experiment ends, you risk making more false positives, or maybe more false discoveries. And of course, that only applies if you are running t-tests. So this answer may not go well with product managers because, of course, you would like to protect your business by making more flexible decisions. And so this is how experiments with adaptive stopping comes in. It includes examples like sequential tests or Bayesian tests, which in the previous talks, some of them has been covered. And in my opinion, the key feature of having experiments with adaptive stopping is that it could help you to decide when to stop experiment based on the data you observed so far without compromising the stats validity of false discovery or false positive rate control. And that is a good thing because it helps us to make much more flexible decisions. And that translates to better business growth because of a quicker experimentation lifecycle. As I said a few minutes ago, there aren't any data set that could support the method of running experiments with adaptive stopping. And this is bad because people will have to rely on simulator assumptions, or which is bad to validate real-world scenarios. And again, I'll just say, well, be the change I like to. And so what we did is we decided to open source a dataset that could help support the design and running of experiments with adaptive stopping. The ASOS digital experiments dataset contains aggregated and anonymized results from multiple real experiments being run by a particular business unit in ASOS in the past. It contains intermediate checkpoints on how the metrics will evolve over the experiment duration. And not only it could help the design and running of the set experiments, it could also have multiple use cases in the experimentation space. It could help run meta-analysis, and you could also use it as a quasi-benchmark for some modeling purposes. And that's how our applied research got to NeurIPS. So we built a taxonomy, and we also provide a mapping between stats tests and the datasets. We populate the taxonomy with the datasets we can find on the internet, which is not that many, and where there are gaps, we enrich it with one of our own. Here are the QR codes. Please check our paper and dataset if you're interested for more on datasets for online control experiments. Now, I've described what I've done to build the foundational data and experimentation capability to help people to measure the impact of their digital products and service, I'll hand over to Angelo to talk about one of the actual digital products that we help measure.
Thanks, Bryan. Right, so I'm going to talk about personalizing search, which is an A/B test we've run recently. So I'll start with, what does it mean, personalizing search? So essentially, our users, depending on who they are, they will see different results when they type exactly the same keywords. So why should we do this? As Duncan mentioned, we have a lot of products always live on our site. So it can be a bit overwhelming for our customers to find what they're actually looking for. Also, if we don't always show things by the same order, we avoid having some products that almost never get seen. And we avoid having this very long tail of products that end up sitting in the warehouse that never actually get a chance to be bought by customers. And finally, we need to make our propositions locally relevant. Think codes in Australia in June. That actually makes sense. Doesn't make sense in the UK. So we need to adapt this visibility of these products based on where people are actually doing these searches. So what do we actually need to then build this system? We need to understand the search term. So when people type their search in free text, what do they actually mean by it? We need to understand the product. We have product titles. We have lots of attributes like the type, the color, the shape, and so on. We need to take all of that information. And that takes me to point 3. So how do these two things actually match? How do we know if a product is a match or not for a search term? Finally, as I was mentioning, we need to personalize the order of the results. So we need to figure out if the products are relevant or not for these users in their specific geography. So we can kind of break this problem apart into these two main questions. What is relevant? And that concerns, do the products match or not the search term? And the second question is this actually a match for this customer's taste? We train these two things together. Let's dive deep into the first one. So understanding the search term. We are a global business, so we have stores across different countries, and that amounts to 10 different languages that we actually have to serve. So when someone types something in the search box, that could be in any of these 10 different languages. So to get a head start on this problem, we use a pre-trained universal sentence decoder that is multilingual for semantic retrieval. So this model has been trained on a large corpus of text across different languages. And what this model does for us is that it will encode sentences that have the same meaning in different languages in a very similar way. So that gets us a massive head start. So we freeze this model, and we put another dense layer after this to tweak it to our particular task and our particular searches that we see on the site. We need to understand the product. For the product title, we use exactly the same approach. So it's some free text. We use the same network, same exact setup. Product attributes, they are different. So there's a lot of tabular data going back to product types, brands, colors, shapes, patterns, et cetera, et cetera. So there's dozens and dozens of these attributes. Most of them have a high cardinality. So if we were to just, let's say, do one-hot encoding with this, we would end up with quite a big vector that wouldn't be so nice for a neural network to actually handle. So we use a hash trick. So that allows us to control the actual dimension we would like to use, and it's much more neural network friendly. So we take these two things, we concatenate them, and then we fuse them in this dense layer. So this dense layer ends up being the representation of the products for matching it with the search terms. How do we then actually do this? So we have the product data, we have the search terms. We need to train a model that determine if the two are a match or not. So we rely on user data. So we have data about what users searched in our digital platforms, and we use that to determine if it is a match or not. But I'll go into more detail on that in a second. Finally, the last problem we need to solve is what matches the customer taste. So we had an existing recommender system. So we had embeddings for products and users that we had trained already. So we start from those ones, and we just fine-tune them to this part of the experience, the search. So we add dense layers after each of these inputs and tweak them to work well for our search pages. Now let's look at how we actually train this model. So we have data about the user session. So we know that this customer came on the site, they typed this keyword, and then they saw a bunch of products, and then they click on a few. So the ones that they clicked on are our positive examples. Out of this, we can tell that they are relevant, and they also match the customer's taste. That's great, but this is a binary classifier. We cannot just deal with positive examples. We need to have some negative ones. So we use negative sampling. We randomly permute the search term, and we get a new example where the relevancy is no longer actually true. It is false. So this customer still likes this product. It matches their customer taste, but this is no longer a product that is relevant for this search term because the search term was now chosen at random. We still need to find another example where the customer taste is negative. So to do this, we just randomly shuffle the customer. We still have an example where the relevancy, it is true. However, in this case, the customer's taste is now false because this is not a match for this product. So to recap, we have all of these branches. So each of them is solving a very specific problem. So the relevancy branch is determining if the search term and the products match. The personalization branch is determining if a customer and the product match. So is this product a good match for this customer's taste? And we train them both together. So we can do this offline, and we can tell if it's performing as expected, if all of the metrics look nice. However, we need to serve this live, right? So for this to be served live, this needs to be fast. So a way to get some speed is to think about what can we actually pre-compute. So the product branch at the top, most of it's static. It's our product catalog. So everyone will always want to know if their search term matches the product. On the bottom, the customer and product embeddings, they're also static. They're not going to change all the time. The only thing that changes all the time is the search term. So people can just come up with all sorts of searches that we have never seen before. So it's free text. It's any combination. People can just type whatever they want in all of these languages. We cannot pre-compute that. However, we can pre-compute everything else, and that's going to help us. So our serving model then looks something like this. All of that complexity and time constraint kind of goes away. We pre-compute the product information embedding. We pre-compute the customer embedding and the product embedding for personalization. And we're left with the search term that at inference time will need to be computed on the fly. So this pattern we're using here, it's a known pattern called a two towers architecture. And what that gives us is the ability to pre-compute everything in advance and then be left with a very cheap computation at the end, those dot products. So they are quick. Everything that is slow has been done in advance. So at serving time, we're left with getting a search term, comparing it against that product information embedding, and determining if these products are or not relevant for that search term. However, this is still not personalized. So everyone will just see the same stuff. So that's where the personalization branch kicks in. So out of that set of relevant products, we're now going to sort them according to the personalization branch. And that takes us to our final set of search results that is now ordered according to the customer's taste. However, to actually get a model live, served, speed is not all. There's other constraints to consider. Scale. Yesterday we went through Black Friday. It's not a day like any other. So we need our system to scale. Cost. We always would like to reduce the amount of computing resources we need to get this service to be effective. As Bryan was mentioning, experimentation. This is a type of system that doesn't just get built once and then we're done with it. We need to iterate over it all the time through A/B tests to keep making it better and better. And finally, geo-redundancy. So we have customers across the globe. So if someone in Australia types something into the search box, we cannot have that request coming all the way to the UK and then back. That would lead to a very high latency. So we need to deploy this system in many different geographies. So finally, I would like to take you to a simple summary of all of the components of this project. So we essentially have a library of core code that is done in Python and TensorFlow. All of the data wrangling has been done in Databricks Spark. We then have a set of pipelines that executes the common stages of any machine learning project. So think data set generation, model training, evaluation, deployment, and so on. So all of those pipelines run on Azure Machine Learning Compute Resources. As a result of this, the model gets published into a model registry, which then gets picked up by a Kubernetes running TF serving. So TF serving here plays an important role because whenever we want to update our model, we cannot have downtime. So we need to push a new model while the old model keeps serving all of the requests that are coming through. So TF serving solves that problem for us. So finally, we're live on the App Store with this experience. So if you are a recognized customer, you can try it for yourself. And now I'll hand it back to Duncan.
Cool. Thank you very much, Angelo. I should add, if you want to understand the difference between your personalized experience and your non-personal experience, if you just sign out on the app, then you'll get the generic recommendations. So yeah, it's kind of cool to try out. So I'm just going to do a quick wrap-up before we'll take any questions that you have. So what are the three main things that we want you to take away from this talk? Number one is cross-functional work is at the heart of everything that we do. We've tried lots of different ways of working, and we think that being as cross-functional as possible is really important. We have to engineer all of our machine learning systems for scalability. As Angelo just talked about, we have customers all over the globe. We have sale events that put our requests per second through the roof. So all of our systems need to take this into account. And finally, research is part of our drive for scientific excellence. So research is really important to us as a team. And we really enjoy giving back to the AI community through publishing the work that we're doing. So yeah, we're at the Data Science Festival. Obviously, we're hiring. I just want to highlight some of the networks that we have at ASOS that kind of for more underrepresented people in tech. So we have the ASOSers, and this is a community for LGBTQ+. We have the Race and Equality Hearts Network, we have a Disability Network, and we also have a Women in Tech Network, and they're all doing great work. So if you want to know anything more about those networks, please come and ask us afterwards. Other benefits are you get 40% off, so it's pretty good. And yeah, I think we'll wrap it up there. So if anyone has any questions, we're happy to answer them. If there's anything in this talk you want to know more about or anything, just come downstairs. We have a booth and talk to us.
I think we should get a round of applause first. Thank you.
Thanks very much.
Okay, for the questions, if anyone's got a question, please raise your hand. If the speakers could just remember to relay the question back for the benefit of those that didn't hear it and
Sure.
also the video. Yes, the gentleman at the back with the beard. Yes, you.
I think it's a question to Bryan. You mentioned sequential testing very briefly. What's your kind of favorite framework, or what do you use in ASOS? If you do.
That is an extremely hard problem, hard question. I think there are a few advantages or disadvantages of using sequential testing. We currently implement a form of sequential testing within our internal experimentation measurement dashboard. And the goal of it is, instead of more like measuring the value, it's more like being statistically sure that if there's a harm, it is something that is indicative and we can roll back it quickly. So we're taking more the risk aversion approach rather than the value measurement approach. But otherwise, there are many other techniques that we're using, for example, like variance reduction techniques, so that a normal t-test, we reduce the overall duration that is required to run a standard experiment. And I guess for my team, our objective is actually not to say increase the number of experiments run per se, but actually to reduce the time taken to start experiment until the time where you can make a go live rollback decision. So that is one of the focus, and sequential testing is just one of the tools that we deploy.
Thank you. Any other questions? Yes, gentleman with glasses at the front.
This is for Angelo. So you kind of touched upon your example. The example you gave is someone types in dress. Now, as a search term, dress is a pretty crap search term because there's so many varieties you can have. So that's the first question. How do you deal with crap search terms? And the second question is, so you talk about the personalization bit. What if you think about like a husband, he's thinking about buying his wife a dress, but his account has no record of dresses in the first place. So how do you personalize with that?
Thanks. Great question. So the first one is, so dress is kind of a crappy search term because it could just have a lot of products. That's actually where this, in a way, shines. Because if it was very specific, you just have, I don't know, a few products to show on the page, then it's fine that if you don't sort them that well. But for searches like dresses or, let's say, a popular brand, that's where sorting it really makes a huge difference. So the second question, so how do we deal in a way with cross-gender searches? So that's, great question. So our accounts, they do have a gender if people want to choose it. The way we actually trained this is that we made it cross-gender on purpose, because we know that we observe a lot of users searching for products that are not a match for their gender. I guess mainly because they're buying it for someone else, or maybe people just have kind of a gender, I don't know, they might be open to buying from different genders. And we actually have part of our collection as unisex. So there's products that don't have a specific gender. So yeah, we in search, we do that. So if you, in a way, search for a dress, even if you're a male customer, we will show dresses that probably will kind of fit your taste, or the type of gifts you probably buy if they would match your own kind of taste. Thanks.
Any more questions for Duncan, Bryan, and Angelo? I think that's it. Round of applause for ASOS. Thank you.